Hello, hello. If you're watching this, you missed day one of our week 3 Foundations of Tech class. Let's get to it. So today, our focus is on deepening our understanding of how electricity works. There is an assignment to be done that is due tomorrow, or maybe today, depending on when you're watching, Wednesday the 17th, and an assignment due Friday the 19th. Both are fairly straightforward. I want to make sure there's no question on either. That was the focus. There is a PowerPoint that you can look at posted on modules, but that primarily has materials for a following um, lesson. So I'm just going to go over these two assignments for the purposes of this video. We went over this assignment. So if you weren't here, you missed out, but let me go ahead and basically give you the answers. But it's so important that you keep these in mind as we go forward, because these are, along with our activity for today, foundational to understanding what is happening when we talk about electricity. So the first top 3 power sources in global power generation are going to be your fossil fuels. It's going to be coal, it's going to be natural gas, and it's going to be oil. Without burning those, we would have basically very little electricity at the moment. The majority of power generating power plants use fossil fuels. However, there's other ways. One such way would be geothermal power, heat that comes directly from the earth. Second way that you could create steam without the use of a fossil fuel could be nuclear power. So nuclear fission, taking an atom and splitting it apart, generates a lot of heat. You use that heat to boil up some water, you have steam. The third, and probably most interesting way, is what is basically a giant mirror that takes sunlight and directs it at some water to boil it. It's probably the most finicky way. It requires very specific conditions to work, but it's very renewable. There are 2 main parts to an AC generator. You have the rotor, the part that moves, and the stator, the part that doesn't move. So you can have either magnets on the rotor or the coils on the rotor, but one or the other needs to be on the rotor. The stator has the other part, and as long as either the magnetic field itself is being switched or the coil of wire is being rotated inside that field, you're going to excite some electrons to move. We typically have 3 coils of wire in the stator. What is the benefit? Well, usually the idea here is you can have electricity in 3 phases. If you have 3 phases, you don't ever have a time where there's no current flowing through your system. This is important so that your lights in your house don't flicker on and off all the time as the giant turbine somewhere is spinning. So we don't want to just have 1 coil of wire, we want to have more, and 3 seems to be a good number. This also allows you to transport electricity more efficiently across 3 lines. If you ever see a high voltage power line, you'll see that it has 3 sets of wires. It's because there's 3 separate phases that are generating electricity in a power plant somewhere far away. The last question I cannot help you answer. The last question is for you. Please actually do this. Don't just make up numbers. It's more meaningful that way. Find a sticker on an appliance somewhere in your home. Look for voltage, this thing called hertz, and this thing called amps. We're going to talk about what each of those are today and in a future lesson as well. I just want you to find them for right now, and we will come back to this and do some math with it a little bit later. So that's assignment 2. Now let's look at assignment 3. That's what we did today. Assignment 3 has you watch a video. The video can be found right in the assignment and also in my PowerPoint right here. You need to go through that video and answer all of these questions. So they're in chronological order. It is super important you do all of them. But the most important one is bolded, number 8. This is going to be what we talk about the most. Ohm's law. Ohm's law is as follows. I will go over this one. For the answers to the rest of these, please watch the video again, or for the first time. The video is posted right here. Ohm's law is voltage, V, equals current. We use I to represent current. I times resistance, R. I times R. This equation is going to be foundational to everything we talk about moving forward. It's going to keep coming back over and over again. So you need to remember this. It's V equals I times R, and you need to know what these things are. Voltage is equal to the current times resistance. So please make sure you internalize this formula, because it's going to be really, really important for this class. That's all I have. Thank you for stopping by. Make sure you watch the video if you're missing answers to any of the rest of these. And next time, we're going to be looking at parallel and series circuits. Have a good one.